Successfully deploying applications on the SAP Business Technology Platform, BTP in short, is just the beginning. True value emerges when you can efficiently operate, maintain, and scale them. In this series, we will explore the critical aspects of day two operations. And by the end of today's session, you will have a clear understanding of how to automate infrastructure management, improve operational efficiency, and integrate your BTP services into DevOps workflows. A very warm welcome and thank you for joining our third episode of our series, Mastering Day 2 Operations. I have the pleasure of having here with me Vipin Vijay Kumar, DevOps engineer with focus on platform monitoring on SAP Cloud Platform, and Christian Lechner, development architect, SAP BTP Foundation Technology Office. Vipin is leading the development teams for Terraform at SAP, namely for the Terraform provider for SAP BTP and the Terraform Explorer for SAP BTP. As a person who loves open source, these projects align with his interests very well. Christian is one of the core contributors for all things Terraform on SAP BTP. He loves to improve developer experience, which fits perfectly to Terraform as a tool for platform teams to make their developers' life easier. And now, without further ado, over to you, Vipin.
Hello, everybody. So thank you for joining this session with us. And as the name suggests, what we will be looking at today is using the Terraform provider for real-world setup scenarios, right? And essentially, the idea over here is to be able to use the Terraform providers that have been provided for BTP on your day-to-day use cases. So let's move on to what's the first thing, which is basically the disclaimer, which basically says that the idea over here is that what we are showing is primarily from a learning purpose. So that's basically what we need to keep in mind. And yeah, let's continue. So what are we looking at today? So the primary aspect of day two operations, when we think about, you could break it down into three things. The first thing is administration and operations. The second thing is managing the life cycle of your application. And the third thing is security. Today's session is primarily for architects, developers, and administrators. And we will be looking primarily from the aspect of administration. Of course, when we think of day-to-day administrations, there are overlaps. Now, think of BTP scenario, right? What do we talk about when we say administration? Well, it could be things like managing your global account, your sub-account. And when you think about security, you would be thinking about things like role collections, trust configurations, and the management of your lifecycle is, of course, deploying your application on Cloud Foundry or any other runtime environment, right? So with Terraform, basically, you would have an overlap in all of these. But yeah, the primary aspect over here is the administration and operation of your global account. Right, moving on. The agenda for what we are going to do today is, well, the first thing is we'll have a quick recap of what Terraform and the Terraform provider for BTP is. And then we'll look at what are the challenges of having to run your day-to-day administration of BTP, especially the multi-state setup where you would have a set of Terraform providers. You will have the Terraform provider to manage your BTP account, and then you would have another Terraform provider to manage the lifecycle of your applications on the different runtimes. And then we'll also look at what are the solutions that you could do to help you with this. Yeah, so the first thing is we do a recap of what Terraform is. And for that, the first thing we want to know is what's the goal? Why do we have this? Well, the idea is that you need to be able to provision infrastructure and manage your infrastructure on a day-to-day basis. And the way you do that is you would need compliance. Now, compliance would be probably the way that your organization would have a set of conventions on how you would have the naming convention or the security concepts that are there. The other aspect would also be auditing these changes, being able to track those changes. You typically want to create all these configurations and you would want to store them somewhere securely. You would have to have some version management over there. So these are the different compliance aspects that we would always want to have, right? And that's the idea. Now, from that perspective, the most common approach is using infrastructure as code. And the most common tool that we use for that is Terraform. Now, the way Terraform works basically is that you would define what you need and you really don't have to bother about how it has to be created. So that's the unique perspective that Terraform gives. And the way it does that is that you would write a bunch of configuration and Terraform would then use that configuration to create your particular resources. So what happens behind the scene is that you would write your specific configuration, whether it's, let's say, to create a sub account or maybe to create a role collection. And then what would happen is you can preview all those changes using the Terraform plan command. Now, what happens is that Terraform uses two things. One is the configuration file, and the second thing is called as a state file. The state file is the complete source of truth for Terraform in the sense that every change that Terraform does on your infrastructure, it's going to store that as a source of truth on the state file. And every time you make a change on your configuration, Terraform is going to basically compare that against what is present on the state. And depending on what the differences are between the configuration and the state file, it's going to apply those changes onto your infrastructure. That infrastructure could be anything. It could be SAP BTP, it could be AWS, GCP, whatever it is. But the idea is that the comparison is done, a plan would be shown for you to see a preview, and then of course you could move ahead and apply that. Yes. Now, why Terraform, right? First aspect is that Terraform is a very large ecosystem. You have a large number of users and we have a large number of providers already present in more than 3,000. So it's kind of an industry standard when it comes to infrastructure as code. The second aspect is you need to be able to have a rather easy way of doing automation of and management of your BTP resources, right? And the Terraform CLI becomes a very seamless way of doing that for you. And the final aspect that we spoke about is governance, right? You need compliance in the way that you do it. You follow a specific approach. And we already know that Terraform has kind of become standard. So it makes sense that you would go ahead and use something like Terraform when it also comes to being the most compliant in your automation perspective. Yeah. So the next thing that we also want to add over here is that the provider that we've built in essence is whenever we say Terraform, we not only talk about Terraform, but we are also speaking about OpenTofu as well. So all the statements that we make about Terraform is valid for OpenTofu as well. Yeah. Now the challenges. So handing it over to Christian.
Yeah, so also welcome from my side. Let's now dive a bit into the challenge that you probably run into when using Terraform and when automating your setup on SAP BTP. Let's take a closer look what you will be facing from the point of view of requirements that you have. So let's first start with the basics. Of course, we want to provision a multi-stage environment. We will structure this multi-stage environment via sub-accounts. So we would like to have one development sub-account, one testing sub-account, and one production sub-account with, of course, things in there like entitlements, service instances, app subscriptions, and alike. Now, as we've been already stated, we, of course, also need a runtime. And for this session, we decided to go for the Cloud Foundry runtime. So this setup will not be only about setting up SAP BTP, but also setting up the Cloud Foundry environment with spaces and maybe assigning some roles. Then, also stressed already, one important aspect is we want to have a fully automated setup. So what we will show you in a few minutes is something that you can do fully automated in a CI/CD pipeline. There will be no CLI magic, quotes unquotes, on a local terminal or copying around files or something like that, because that's something that you don't want to have in a real life scenario. And then one further requirement that is not immediately obvious, but plays an important role with such a setup is we don't want to have this state file that was just mentioned in the recap. So this memory of Terraform, what it did, as a monolith. So we don't want to have one state file that contains development, testing, environment, Cloud Foundry, BTP, and whatnot. We want to split that. It's the same as you would do for app development. You also don't want to have a monolith there because there are a lot of downsides. And the same applies to infrastructure as code. You want to have the state split up, and at least every stage should have its own state file. Maybe it makes even sense to also split BTP and Cloud Foundry to have their own state files. Now, this is kind of the challenge that we have ahead. Now, in order to make this more tangible, of course, we will have some code to present to you. And there are some assumptions that we make when we present this code. The first one is for the state backend. What we are using in our sample is the Azure Blob Storage. Now, if you are using a different state backend in your company, that doesn't matter. Any state backend will do the trick. Then, when it comes to automation, as we said, we want to integrate that in a CI/CD pipeline. And for the demos that we show, we decided to use GitHub Actions. Reason for that is our code lies on GitHub, so it's quite natural to use GitHub Actions. But if you're using GitLab, Bitbucket, I don't know what, probably any CI/CD tool will do the trick as the features are there. And one important point, we are talking about a real life setup. However, in order to keep this session to 1 hour and not to 3 hours, we will skip talking about safeguards that you would probably implement in the CI/CD flow, like doing preliminary planning when changes hit your configurations or doing checks via policies integrating the open policy agent. So this is something that we will keep out of this session. Nevertheless, you of course have to wrap your head around there. And one further point is when you have experience with Terraform, which I assume because we are in a day 2 webinar, please keep in mind that we implemented all the examples in a kind of extreme fashion. So we wanted to go to the extremes of the color spectrum, black and white. We will not have any gray in the examples. However, there is always some gray in real life, so you could adjust the code a bit and move it in this color spectrum. But just keep in mind, we did that intentionally, not by any bad mistake. Now, we have talked now about the requirements, about the assumptions that we made. Now, how can we do such a setup, or how should such a setup look like and feel like? So let's maybe first say, what is our vision? What is our goal, what we want to achieve with this automated setup? We don't want to set up infrastructure via Terraform for the sake of setting up infrastructure via Terraform, right? So let's shortly switch to a scenario where we talk about a development project that starts. And this development project wants to have such a setup in your landscape. And in order to do that, it opens a new issue in a GitHub repository and says, I want a sub-account request and I want a new landscape for my development project. And the project name should be FinApp because it's an app in the financial service area. I will give a cost center because cost centers are important. I have to specify a sub-account region. I will go for US 10. And then I have to enter a responsible for the space because I want to have somebody in there who can then onboard maybe other users. And I will put in my email address there. And then that's it from my development team perspective. I don't have more information. Honestly, I don't care what's happening on the platform. So just say, hey, create me such an account, and then maybe give me back the information that I need to onboard. And with that, a GitHub Action workflow gets kicked off. That creates me all the 3 stages. Now this takes a bit of time, so that's why we already did that beforehand, just to show that this is how it looks like. And if you dive in, you see there is some Terraform action going on all over the place. And as a result, the request from our dev projects get updated, and we can directly jump to the necessary bits and pieces that we need for a development project, like the URL to the sub account, the CF API endpoint, and so on and so forth. And to show you that this really works. So it's not just updating the GitHub issue with some fake data. We will shortly jump to the cockpit. And as you can see here, we have a production environment called FinApp. We have used for production. We have better features disabled. We have some labels here, which display our cost center and our stage. So this is kind of the idea. That's kind of the goal that we want to achieve with this infrastructure setup. Now, what options do we have from a Terraform perspective to achieve that? And there are three options that we want to present. First one is the directory approach, so structuring things mostly about directories. Then we have the Terraform Workspace approach, which is a feature of Terraform. And then we will also take a look at third-party tools. Because as Vipin already said, there is a huge ecosystem around Terraform, and there are a lot of tools that are worth a look at, and we will specifically take a look at Terramate. So let's jump right into the first approach, the directory approach. And as the name already states, what we will do is we will structure every stage of our setup via a dedicated directory in the file system. So we will put our configuration per stage in such a directory, and we have then one dedicated configuration for dev, for test, and for prod. All the settings that we do are quite explicit, and here we are kind of at the extreme of the color spectrum, so we will really set everything that we can set explicitly. We will set it explicitly in the configuration. And consequently, if we have those directories, when you structure your deployment, you probably have to structure it not only around the stages, but you also have to know where is the stuff lying around in the file system, namely the directories, in order to instruct Terraform to do the right stuff for you. Without further ado, I would say let's take a look at the code, how something like that looks like. And for that, we will jump over to VS Code. And what you see now is a setup. It's exactly the setup where I just created the issue from, where we have one folder which is called infra, probably the infrastructure. And what we immediately see is this folder contains the three different stages that we want to model: the dev stage, the prod stage, as well as the test stage. And within those folders, what we see are the different environments that we want to provision, so BTP and Cloud Foundry. The configuration per se, if we take a look at the folders, if you are familiar with Terraform, are quite easy, quite self-explaining. We have the main configuration, we have the provider setup, we have some variables. So everything is where it should be. Now, of course, this is always the same through all out the stages. Now, when it comes to the configuration per se, what we have is we have our provider, our BTP provider that we configure. We have a partial configuration of our backend. As I said, we use the Azure blob storage as that one. And we have our provider configuration. Then, as the demo already suggested, we have to hand in some information to get the configuration going, which is purely the business information, quotes unquote, that a development project would provide. We have the project name, we have the sub-account region, we have the project cost center. We could provide a CF landscape label, but that's optional. And with this input, we then can configure our BTP sub-account. Now, as we only have this kind of business information, we have to massage those variables a bit to get it in a shape and form to provide our resources. So for example, we have here this locals block, which then creates a local variable where we have the dev stage as part of the name, as well as part of the subdomain. We also have it as a stage label. We hand over the cost center via the variable, and so on and so forth. Now, besides the sub account, of course, we have several other resources that we provide. No special stuff here. We have entitlements, we have subscriptions, and we create the Cloud Foundry environment. One point worth to mention is for the stage-specific configuration, as I said, we will do this quite explicitly. So if we are on the dev stage, we say beta enable is true. If we are on the prod, we would probably disable that and set the corresponding label also for the usage parameter. Now, as we have to provide BTP resources as well as Cloud Foundry resources, we also have some outputs that we have to hand over to the Cloud Foundry provider in order to be able to initialize that one. And then the Cloud Foundry provider could use the CF API URL as an input. And then we create a space and create 2 space roles. So nothing too fancy happening here. Now with this setup, we now could, or with this configuration, we could now set up our CI/CD workflows. And for that, as I said, we use GitHub Actions. Now you don't need to be an expert in GitHub Actions. I will pinpoint you to the important steps that we do. They don't look that different in the different CI environments. First things first, as I said, we are in a directory-based approach. So we have to tell the action, where are the different scripts, the different Terraform scripts located. So we have here 6 variables where we define, hey, this is where we have to go. And then for each stage, we have to do the setup as we saw in the pipeline. We first start with the development setup. We have to do some pre-work. And then the main part comes with the initialization and the application of our Terraform configuration. And to do so, we basically trigger the main commands that you are probably familiar with. You initialize Terraform. And of course, we have to tell Terraform, hey, I want to initialize now my dev environment. So please change the directory to the corresponding area to our path to df script BTP dev. And then we can continue with the application. Of course, we also have to provide the missing information for the backend configuration, where we also hand in the stage as part of the key for the state. So we get the separation of the state. And then we apply the change as you would do it also locally. So you change into the directory and apply the change. Then, due to the fact that we also have to apply to provision Cloud Foundry resources, we have to do a bit of, let's say, magic to hand over the output from one step to the next. That is probably dependent on your CI/CD setup. And then we do the same initialization for Cloud Foundry for the dev stage. So there is no real difference here. We initialize it, we have to point it to the right directory, and we're good to go. And then, of course, we have to redo that for each and every stage that we want to provision within our workflow file. With that, let's switch back to the slides. Because as you have seen, this directory approach, you could do the configuration via Terraform, and you can then also provide everything via CI/CD, in our case, GitHub Actions. Nevertheless, there are always considerations that you have to make, because every approach comes with advantages and maybe disadvantages. For the directory approach, I think we can agree that it's very intuitive. It's very easy to navigate the structure, and we have a very clear separation of our configurations. So that's kind of very easy to understand and very good if you're starting with Terraform. Now the configuration, as I said, we really made that super explicit, and it's also easy to understand therefore. So if you have some troubleshooting to do, you immediately know. If you have something happening on the dev side that doesn't work, you know where to look, you know the parameters. Same, by the way, goes for changes. If you change something on dev, this wouldn't impact prod, at least not immediately. Now, there are some downsides, of course, of this approach, and I think there are quite obvious. We have all those different directories. We have all the code all over the place. So we have a lot of code duplication there. This is something that you wouldn't want within app development. You also probably don't want that in your infrastructure as code setup. This leads to an increased maintenance effort, because if you have to change something due to a bug fix or due to a change due to your compliance regulations, you have to do the copy-paste exercise. And due to the static configuration, which is of course great because you immediately see what happens where, you reduce the flexibility a lot. Now, as I said, this is kind of the very extreme part, how you would implement that. And there are measures to mitigate some of those, like introducing Terraform modules or putting in some more variables. Nevertheless, this will come at a price, which means less intuitivity around navigating the stuff. Having said that, from my perspective, this setup is a very good fit when starting with low complexity setup, when making your feet wet with Terraform and starting to do the setup. Now, as we can see, there are some downsides, and maybe there is an approach which helps us, which still keeps our state configuration separate, so we don't run into this monolith or teralith, how it's called, but still get it going. All right, so that's where the second approach comes into play, and that's I call the Terraform workspace approach. Why? Because we use a feature of the Terraform CLI to create so-called workspaces. Now, Terraform workspaces exist in two flavors. One is the Terraform CLI workspace, and the other one is the one on the HashiCorp Cloud Platform. And they are a completely different ballgame. We are focusing here on the Terraform CLI workspaces, which are part of the CLI. And we will use that in order to keep our state separate, using Terraform CLI, not using some approach like before, where we also split the state via the directories. Now, this means that we could reduce the code and use one configuration, or let's say two, BTP and CF, for all stages. We therefore have to make the setup more flexible, which means we have a bit more of parameterization to do and a bit more of logic in the configurations that we will see in a second. And when it comes to the state, the separation of the state, which is an important requirement, we can do that by leveraging the Terraform CLI workspaces. Now, let's take a look at how this would feel like and look like in the way how we would craft a Terraform configuration. And for that, let's switch to the setup for the workspaces. And what we will see here now is, from a first glance, exactly the same structure as before. We have an infra folder, we have this .github folder. But now, diving into this, what we see is we have now only two more folders because we don't distinguish the stages by directories. So we have now only a BTP and a Cloud Foundry configuration. So we reduce the code to the max. Where do we kind of feel that? Well, for the variables, we have one more variable that we need to bring in, and that's the subaccount stage. We have to hand in the stage to the configuration in order to know where we are. In the main configuration, this then is reflected, of course, by replacing the hard-coded stage information from our naming conventions by introducing the variable and bringing that one in. But that's not the only point where we have to do and make an adjustment. We also have had a setting of attributes of our resources that was hardly connected to the directory, which was connected to the stage. So now we have to jump those two hops back and define those settings, which was the beta enabled as well as the usage attribute, and map that based on the information that we get in from the stage. And for that, what we use here is the so-called ternary operator, which is basically if then else, where we distinguish how to set the attribute. And for the stage dev, we want to enable beta features. For all the other stages, we don't want to do that. And for the usage, we want to set used for production if it's production and not used for production if not. And consequently, this is then something that also goes into the resource configuration. Now, for Cloud Foundry, the change is minor because we just have to replace where we have hard-coded the stage with the new ID. And that's basically it. Now, with that reduced setup, how would then look like when we do the provisioning, the automatic provisioning? Let's take a look. So this is now the GitHub action that takes care about the provisioning of this setup. We immediately see, oh, wait a moment, that was much more, this definition of the where does my configuration lie. We now just have two directories for BTP and Cloud Foundry, and that's it. And provisioning now the different stages, we once again jump to the main part, the initialization and the Terraform apply for BTP. So for the initialization, of course, we have to tell Terraform where our BTP configuration lies, but that's it. So we don't have to distinguish the stages here. We do it the same way for all the stages. And then what we have to do different is the apply phase. So for the apply phase, what we see here is, of course, we have to hand in this new variable, this dev stage, so that our configuration knows where it is. And then we have to tell Terraform, I want to work from now on in a very specific workspace. So in this kind of virtual environment that allows to split the state between those different workspaces, which in our scenario map to our stages. So what we do is we say Terraform workspace select. Probably you have not come across that command yet, but this is basically telling Terraform, hey, I now want to have or to work in the dev stage. And I want that you put all the state information into this workspace. And once I switch the workspace, I want to have a different state to be filled up with the information that Terraform provides. And after we have switched that stage, what we will do is we will then apply our change. So this command stays the same as before for the directory, but this one is, of course, important for our approach. Now we have to do the same magic to transfer information from one stage to the next, namely from BTP to Cloud Foundry. And then we have to do the same exercise that we did for BTP for Cloud Foundry. So we have to initialize Terraform for Cloud Foundry. And we have to apply the change by first selecting the workspace and then executing our Terraform application. Now, as you can see here, this really implicitly also sets our key value for our state, because we do not care how the backend is now really configured with respect to the key where the state is stored. This is all done under the hood by this workspace select command. And then, well, we have to do the same exercise for testing and production. That's not different to the approach before. And that's basically it. What's all about the approach for workspaces. Now, as before, let's shortly look at what to consider when we go down this path. So we don't have any code duplication when it comes to the different stages. That's good. So we have one configuration for BTP, one for CF, everything is there. If we have to do some bug fixes, we can do it there and we don't forget any place where we have to do it. Then the setup is quite flexible. So if we would introduce new stages, and depending on how flexible you are with respect to the attributes that you provide, it's quite easy. You don't have to jump from one directory to the next. So it's less effort to maintain that, that's for sure. Now, there are also, from my perspective, then downsides or things that you have to consider compared to the directory approach. The infrastructure definition becomes more complex. The degree of how much does it become more complex depends on how flexible will you be, how much if then else stuff do you put into your configuration to be able to have everything in this one code base. That's something that you have to wrap your head around. Now, of course, as a consequence of that, the infrastructure configuration is not as self-explanatory as it was before, as with directories. Because you now do not see immediately how a certain value is set. You have to kind of go down the data flow and say, okay, the variable is set to that. If the variable is set to that, the local is set to that, and then the attribute is consequently set to this value. This is something that is the price that you pay, and there is also another price that you pay. If you, oops, that was too fast. If you have the risk of changing something, you now impact all stages at once. So you have one code base. If you do the changes there, you have quite some impact. This is something that you would not have had in the directory approach. So consequently, this is probably a better fit for companies with Terraform experience that want to rely on the Terraform CLI features only. So if you really want to stick to vanilla Terraform and don't want to kind of move out of this ecosystem, and you also don't want to stick to the directory approach or similar approaches that are there, like branches in your GitHub repository, then you probably end up somewhere here. Now, if you say, okay, I have this challenge, the workspace approach is something I don't feel comfortable with that. However, I see the advantages, and the directory approach, I see also the advantages and disadvantages. Isn't there something that could help me with that? Because probably I'm not the first one to face this. So that's where third-party tools come into play. Talking about third-party tools, the Terraform ecosystem, as we've been mentioned at the very beginning, is a super huge one. So there are tons of tools for different challenges, for different requirements that are maybe not covered by the Terraform CLI and that are covered by those tools. These tools come in all variants, so free, commercial, open source, closed source, whatsoever. And one choice that, of course, immediately comes to your mind when you're talking about Terraform probably is HashiCorp Cloud Platform, which is the commercial offering of HashiCorp Terraform, which, as I said before, comes with more sophisticated workspaces. I would say completely different workspaces, to be honest, because those are really confusing concepts. But it comes at a price, which means you have to pay money for that. Now, we want for this webinar to stick to tools that are free, quotes and quotes, so open source tools, and we want to present Terramate. Now, when we talk about open source and free, be aware that the open source word is free like in free speech, not free like in free beer. So if you use open source, I highly recommend to also be a good open source citizen and contribute, for example, via feedback for those tools. Having said that, let's take a look what such a tool could bring to the table to handle those requirements that you have. And Terramate is a very good fit for the setup that we are discussing, because Terramate provides several features that combine the pros of the options that we just discussed. And there are two primitives that Terramate is built around, and one is code generation. So this allows you to have a very flexible definition of your configuration, like in the workspace approach. But you then generate the real infrastructure code, which then again becomes very easily readable as in the directory approach. That's one point. Second point is the Terramate CLI is, and that's one important primitive, an orchestrator. So you don't have to use a different CLI to do the things. This CLI does not replace Terraform or OpenTofu. It just orchestrates everything. So you can still use, or you will still use, the Terraform commands, but the Terramate CLI will orchestrate that stuff. And what's also an advantage in contrast to other approaches is that Terramate is using the HashiCorp configuration language for defining everything. So there is no additional language to learn in order to make this reality. So you have no learning curve there. Of course, you have to learn the concepts and the approaches that Terramate CLI comes along from a conceptual side. But working with Terramate feels quite natural because it's the same language that you anyway used. So without further ado, again, let's look at how this feels like when looking at the code. We go now here, we make it a bit bigger. And what we see immediately is we have a very different layout here of our code. So we have a lot more configuration here. We have a templates folder, we have a stacks folder. Okay, as I said before, we do code generation. So probably we need code templates in order to make that generation, and that's exactly what is lying here. So here we have our templates for the main file for the BTP configuration. And as you can see, that's pure HashiCorp configuration language. Same for CF. So that's the reason why we have this folder. And what we see immediately is, okay, there are some functions that I've not seen in the Terraform world. TM, probably Terramate, contains. And then we have some stack tags. Okay, that seems to be a Terramate concept that comes into play. And this is where the second folder originates, the stacks folder. Stacks are a concept of Terramate, which you can think of some self-contained unit of infrastructure as code configurations. So a stack is kind of one such a unit. And when we open this folder, which now hosts our generated infrastructure as code configurations, we again clearly see the structuring according to the different stages. Now, what makes a stack a stack? There is one configuration that is important, and that's this stack file. And this stack file adds some semantics to your stack, some metadata that allows Terramate to interact with this stack. And what we see is, well, it's again, HashiCorp configuration language, first of all, but we see there is a name, okay, we give the stack a name, makes sense. We give it a description, makes also sense. And then we have some tags. So we could feed in this semantic information. This configuration is for BTP, this configuration is for the stack dev, or for the stage dev, I have to say, into this part of the configuration, which then allows us, first of all, to steer the code generation, as we have seen before. So if we jump back, we have here this condition. But this also, if we think a step further, might help in orchestrating the different things. And what we also can define here is we can define dependencies between stacks. So for example, we know that the Cloud Foundry part should be executed after the BTP part. And this is something that we can model. We tell Terramate, hey, this stack should always run after the stack with the tags BTP and dev, because otherwise we are running into issues. And this is, I think, also an advantage then with respect to bringing the knowledge about BTP into the code. Now the rest is generated. So as we said here, we have this generated. And as you can immediately see, this kind of resembles a lot more our directory approach. We have this explicit setting of environment, of attributes all over the place. And the cool thing is that Terramate is quite smart. So if we now say, okay, let's just delete that file, I can say Terramate generate. And Terramate will recognize, oh, there is one file missing that isn't generated. Maybe weird, but here we go. And we get it back. Now we could also change something in the generated files, which we should of course never do. But we can heal that immediately by just keying in another Terramate generate. And we are back again at our original code. So this is really something that this code generation feature from my perspective is really powerful, really helps a lot in keeping the stuff maintainable, keeping your code base dry so you don't repeat yourself. You have all the templates at one place, and then you just generate out the code. And you don't sacrifice this advantage to really being able to take a look at what's really happening in the stacks. Now, when it comes to CI/CD, let us take a look at how this now looks like in the GitHub action when we use Terramate. So first of all, what we immediately see is we don't have to put in any information where our stacks are located in the file system, because we have this stack information, this metadata that we can use to orchestrate things. And besides all the pre-work, we then, of course, have to initialize Terraform, and then we have to execute the deployment. Now, here, what we do is we, of course, again, do a Terraform init command, but we do not just do the Terraform init command. We orchestrate it via telling Terramate, hey, run this Terraform command or OpenTofu command, it doesn't matter, and execute it. And in order to steer what or where it has to execute this command, we use the tags. So we say, hey, use the tags, in this case, dev, which is hidden in the env.stage variable, and execute the Terraform init in those stacks, and of course also respect the sequence. Then next, we execute the deployment. Now for that, we use a different concept in Terramate, which allows you to combine Terraform commands in a script. And this is done here, so no need to know the details here, but you can define scripts, you give them a name, and then you can define their commands and also enrich that with some further, let's say, magic that could help you with orchestrating different stacks. And then you just say Terramate, run those script, which then executes a Terraform command in the backend. And you have to give it, of course, the name of the script. Now, if we take a look or scroll down a bit here, what we will see is we don't have any Cloud Foundry stuff happening here, right? So that's weird, because before we had to do this magic with handing stuff over, and that is where this orchestration beauty of Terramate comes into play. And some other stuff that allows me to tell Terramate, hey, use the outputs of this stack and reuse them as inputs in the next stack. So I can really here massively also reduce the complexity within my CI/CD setup. And with that, that's all around Terramate. So of course I have to do that then for all the other stages. But you certainly agree that this reduces the amount of work in the CI/CD pipeline a lot. Now let's go back to the slides then for the last time and take a look at the considerations that we have. So we saw Terramate now as one tool that you could use, and you saw the benefits that come along. Let's take one step back and make it more generic for the third-party tools. As I said, there are a lot of offerings. You have the choice for your concrete problem to solve. So there are a lot of white spots in the Terraform CLI, and there are a lot of offerings that close those white spots. So you really have to make your choice there. You have to distinguish what fits best to you. Now, depending on the tool that you use, there is not only a positive impact on the configuration side, but there is also a potential positive impact on the CI/CD setup side, as we just saw in the Terramate example. The downside is, well, there are several offerings, so you have the choice. You have to choose, you have to make a decision, and that's always hard. Another point that's of course worth to mention is now you end up with bringing in additional dependencies. So you don't only depend on Terraform, you now also depend maybe on Terramate or on any other tool. And depending on the tool that you choose, of course, there might be additional costs arising on your end. Now, from my perspective, if you start with Terraform and you run into issues, it's always worth to take a look at, are there additional offerings outside that might help me? Because you probably don't get paid for being the greatest Terraform configuration writer in the world. You have to provide stuff to your development teams. And so it makes sense to take a look at what tools are out there, where does it help me, especially if the complexity is growing. So that's, I think, one logical next step. And with that, we have presented you the three options that you have. There are, of course, variants in between, but I think that are the three most prominent points to stress. So what you have seen within this session is you have several options to make such a multi-stage setup, a fully automated multi-stage setup, possible. Every option comes with points to consider. So you really have to you have to look at the options, you have to wrap your head around them and make a conscious decision. Now, we cannot present you a silver bullet, a golden path, because there are several paths out there, and the choice really depends on your setup. How does your organizational setup look like? What's the complexity? What's the requirements that you're dealing with? What's your current experience with Terraform? Where are you standing with respect to the maturity of providing infrastructure in the cloud? I mean, we, for example, didn't talk at all about GitOps, which brings it to a new level. Now, the good point from my perspective is that grow as you go is possible. So if you start with one approach, you always can switch to another approach. This, let's be honest, might be more or less painful depending how far you have driven the approach to the extreme with respect to your setup, but you are rarely in a situation where you get stuck. So grow as you go is always possible. And saying that as a German, don't over-engineer. You will not have the perfect setup on day one. Embrace that it's a journey, embrace that there will be changes in infrastructure as code, and that you will have some learnings that you then can feed in and improve your setup. It's the same as for app development. It's the same as you would do for microservice development. It's a journey, embrace the change. And with that, first of all, thanks for your attention. And we are now having time for questions, I think.
Great, thank you so much. Big thanks, Christian Wiepien, for your excellent and in-depth presentation to this topic. And yes, we do have a couple of questions. I would like to start with the easy ones. In the sense, I think they're quick to answer, sorry.
Sure.
To deploy the configuration, you probably have to have a technical user that is a global account admin, right?
Yeah, for most of the cases, you have to have this technical user in the role global account admin in order to get things going. I think there is no way around that. And for the global or for this technical user, you then can authenticate that one via either username password or via X509 certificates.
Great, thank you. Quickly, maybe you can unshare so people can see
sure.
all of us.
Sorry.
Okay, great. Thank you. Next question, is there an alternative to basic authentication user plus PW for this technical user?
So as I said, there is the option to also have X509 certificates, which trigger the passcode flow internally. But we don't have any more sophisticated flow at the moment available on the platform for the provider. So we're running in the same restrictions as you would run into when using the BTP CLI.
Thank you very much. Now, is there a plan to enhance the BTP provider for destination configurations?
Yes, there is a plan. So first of all, you can already create destinations via service instances. So you can use the service instance resource to create a destination. Having said that, that's a workaround. So you run into some limitations there sooner or later. But for now, you can do that. Now, currently, the colleagues from the connectivity services who own the destination service are re-architecting the destination services, which will reflect in a new set of APIs that we can then use in the Terraform provider to make your journey with destinations more comfortable than it is today. I guess that the next second point that you would then come to your mind is, when do I get that? So I think the API stuff is planned planned in bold letters for this year, end of first half of the year. And then we have to kind of pick things up and bring that to the BTP CLI and then to the Terraform provider. So I hope, keeping fingers crossed, that this will happen this year to make your life easier there, because we are aware that that's an important point.
Great, thank you so much. Now, there is a question which has had already a couple of comments. Christian, I don't think you've had time to look at all the questions.
Nope.
But I will ask it anyway, because I think it might be easier for the people if you answer it live. So how strategic is Terraform for SAP? Background of the question. In the past, there were several different tools to manage BTP operation, Booster, BTP Setup, Automator. Bipin already also answered it, but maybe.
So yeah, Terraform or the Terraform provider, which is available for Terraform and OpenTofu, is as we said, the gold standard or the de facto standard for infrastructure as code. Now, we don't want to reinvent the wheel when it comes to this automation and setup stuff, so that's why we use it. Based on the demand and based on what we know today, this will stay for the foreseeable future as the tool to provide infrastructure as code configurations. So it's strategically set. Having said that, I mean, we all know there is a lot of movement in that area. Maybe that will not stay the only tool that we support, but for the foreseeable future, it is.
Thank you very much for the clear answer. Now, the next question is, are there recommendations for the entitlement management with new sub-accounts? With the creation of a new sub-account, standard entitlements are added, for example, in the path application logging services. This could lead to inconsistencies when SAP is changing the standard setup for new SAP BTP sub-accounts.
I don't have an immediate solution for that. So this is also, to be honest with you, a point where we are currently taking a closer look at. Jumping ahead to the webinar next week, making some advertisement there, because this is a serious point to take a look at when you do especially import of existing sub-accounts. So you have, at the moment, from the top of my head, I would say, yeah, you have to get the inventory of a sub-account once it's created and then check if something changed there. So there is no measure from our end or from the provider end to close that gap, or we also don't have any machine readable information on what gets provisioned when you create a sub-account by default by us, at least not for the external world.
Great, thank you. Now there is no direct question in the chat anymore. There are several comments and suggestions, which we will have a look at later. But actually, there is one question which from the Global User Groups, in general, we often get questions, how best to start. So, if someone starts from scratch, are there, and are just building up, their Terraform knowledge, what would you suggest would be the best starting point?
Then I shortly have to share again.
Great, thank you.
Because we have something. So you should now see my screen again. And the slides are anyway shared afterwards. Also, worth to mention, all the code that I showed are available on GitHub, and we have the references in the slides that are shared. So you can directly jump into the code and take a look at that. But if you now get started with Terraform, so you're not in day 2, but you're on day 0 or day 1, we have just published a new course on learning.sap.com that's called Getting Started with Terraform on SAP BTP, which guides you through your first steps with Terraform and then also moves forward to some more advanced topics, focusing purely on SAP BTP as well as Cloud Foundry on SAP BTP. So I think if you get started and if you want to get information that is very specific for your SAP use case, then this is the place to go. If you want to learn about Terraform in general, there are tons of courses out there on Pluralsight or whatnot, where you can get the information.
Awesome. Thank you so much. We actually don't have time for another question. We're basically already on top of the hour. So I would like to take the opportunity to again express my big thank you to both experts for today and presenters, Christian and VP. And of course, last but not least, to all attendees for joining us today. I hope you got a lot of value from this session, and I definitely look forward to seeing you again next week.
Thanks for having us.
Thank you, guys.
Have a great day. Have a great evening, depending on where you are.